Hey everyone, hope you're all doing very well. I'm Jeff Hollan. I'm thrilled to be the penultimate speaker here at the Serverless Practitioner Summit. And we're going to be talking today about serverless messaging patterns that can make or break your app at scale. Really, what I wanted to share here were patterns and use cases and lessons that we have learned as we built and are managing the Azure Serverless product offering, specifically Azure Functions, the things that we have learned, the things that we feel are important that will hopefully be beneficial to each of you as you're building and hosting your own platforms, as you're investigating using serverless in Kubernetes, in the open source, and what have you. So I'm Jeff Hollan. I work at Microsoft on Microsoft Azure. I've been there for about 7 years now. Thrilled to meet you if we haven't met before already. For those who don't know me, I'm the general product lead for the Azure Functions service. And so my team's in charge of everything from the service to the hosting to the programming model of Azure Functions. I've been a part of serverless for a very long time now, over 4 or 5 years, I think. I was one of the original members of the Azure serverless team as Azure was starting to build its serverless capabilities. I'm also a maintainer and was one of the original creators for CADA, Kubernetes Event-Driven Autoscaling, which is a CNCF project. If you're interested to get in touch with me, if you have any questions as you're watching this, at Jeff Hollan on Twitter is the easiest place to find me. Okay, so let's jump right into it right away. And I want to start with a story because part of this is going to not just be about using cool tools, but making sure that you're using tools in the right way. And I thought a good way to illustrate this would be a story that I remember from a few years ago. So I had a good friend. Their family always wanted to have the latest and greatest stuff. They had a really cool house. And at one time, they decided that they wanted to get a brand new TV. This is when HD TVs were more new than they are now. And so they went and they bought this massive, whatever, 42-inch, 60-inch screen, high definition television so that they could get that amazing viewing experience in their house. So they spent all this money on this HDTV. They installed it in their house. And I remember they were talking to me once after they'd owned it for about a year. They're like, yeah, it's really cool, but we can't really tell that much of a difference like the HDTV versus a standard definition television. Like this is a really cool tool, but it kind of seems a little bit bland. And so I was taking a look at it. Obviously, I was into technology, and come to find out after I dabbled with it for a little bit, I found probably the source of their problem was they had bought in a Blu-ray player or a high definition cable box or whatever else. But the cables that they were using to connect to their high definition television were these RGB cables. If you're familiar, the yellow, white, red, these do not transmit a high definition signal. These transmit crappy grainy quality. So they'd spend all this money. They had a TV and a cable box and a Blu-ray player, or whatever else, that were capable of showing HD. But because they were trying to do things the way that I always had with this red, white, yellow, they weren't getting a very good experience from it. So it's a funny story. They figured it out, and then they're like, "Oh yeah, this is why we paid thousands of dollars from this television once we plugged in the right, whatever, blue, red, and green cables. You probably component cables back in the day." But I use that as an example because when we think about serverless, serverless is awesome. Serverless is the new hotness. It's a really exciting space. If you look at things like the CNCF surveys that have been happening, there is growing interest year after year around serverless and enterprises and open source projects interested in finding out how can we make it easier, more efficient to build and host these applications. But the caution is, just like with HDTV and standard definition television, don't go about trying to do things the same way that you've always done them and expect them to translate to a serverless world. Or rather, if you do them the same way, if you do them in the comfy, familiar RGB world, just realize you might not be getting the optimal experience. And that sometimes there might be new patterns or new ways of doing things or new messaging constructs that will let you take full advantage of the capabilities that serverless can provide. And so be wary of doing all things in the same way, right? And specifically, I have nothing against HTTP. I have nothing against gRPC. But this presentation is a little bit of don't HTTP all the things. There are other patterns here that are really important that you shouldn't sleep on, okay? Which brings us to an interesting point. So as I mentioned in the intro, my day job is managing and running the Azure Functions service. And so if you just look at the data that we've gathered from Azure Functions, it's been around well over 3 years, maybe 4 years at this point, used by thousands of users, billions of executions every single day. What are some of the things that we can see from how people are using the service? Well, there's a few things, okay? So let's start with what's the most popular trigger? If you think about a function, a serverless function, what is the most popular trigger that people are using their functions for, right? You could guess, okay? So obviously you have like HTTP triggers, there's timer triggers, there's queue triggers, there's event stream triggers like Kafka, there's database triggers, things like Cosmos DB in Azure, which is a NoSQL database. Which one's the most popular? I'll tell you a few things that we've noticed, okay? First and foremost, your first trigger, when you are first starting with Azure Functions, you're creating your first one, you're like, hey, I've heard about the serverless thing, I've got an Azure account, it's mostly free, it is free, you get the first million executions for free, whatever. I'm gonna go build one. More often than not, they start with an HTTP trigger. And that makes sense. If I'm testing something on my local box in the cloud, HTTP is just super easy to get started with. I can test it from any web browser. I don't need to install any other tools. I know how to visit a web page, so I know how HTTP works. So it's super familiar, very easy to get started with, really quickly to test. But as users have grown in their function usage, so now you're not building your first function, now you're building your 50th function. Now you're building your first function meant for production. Maybe your first function meant for a mission critical workload, a function that might be powering something like a Black Friday retail experience. What we see is there starts to be a bigger divergence in the types of patterns that people are using. So while those first few functions might be a simple HTTP or a timer triggered function, doing some really basic automation, a hello world, whatever else, serverless APIs, there's very valid reasons you would want that HTTP function. But we see the population gets much more diverse when you start to look at people who are entrenched in serverless and starting to really take advantage of those benefits. So what does that look like? Well, here's an example. I didn't put any raw numbers here, but I pulled data for the last 30 days. So 30 days ago, if you look at our real production data, all the executions that happened. So there were nearly 500 billion executions, so about 500 billion executions in those 30 days. And this is what made up those billions of executions in the Azure Function Service. So you see a good chunk of them are still HTTP, right? Those serverless APIs, those really simple mobile web backends, maybe serverless websites, you name it, still makes up about 30%, but it's not the majority anymore. The majority really is split. Like, I guess if you did HTTP and non-HTTP, HTTP won't be in the majority, but it's HTTP stream data for us in Azure land. This is Azure Event Hubs, but you could think about this like Kafka or NAT streaming, whatever the streaming protocol, Kinesis, if you're in AWS, kind of Google PubSub. I don't know too much about the specifics of how Google PubSub works. Queues is the next huge one. So this is another huge slice of the pie. It's actually slightly bigger than all the other ones. And this is, a standard queue, whether SQS and AWS land. RabbitMQ is my personal preference for the open source flavor. Azure Service Bus is what we're using in Azure Functions. And then there's the other triggers. So there's a bunch more here, those database triggers, triggering on a storage image, timer events. They're still happening, but they're not pulling in the number of executions that these other ones are. So again, back to kind of the initial tease and premise of this presentation, it's not just about HTTPing all the things. So let's look at some of these messaging patterns that we're seeing and why people are using them. Why does the pie chart look like this? So let's look at one example scenario. Some of our favorite customers in Azure are e-commerce customers. So some of the largest retailers in the world, whether it's Walmart or Best Buy or whomever, are publicly using Azure. And many, if not all of them, are using serverless functions as part of their architecture. So here's some example qualities that one of these large e-commerce customers would require when building a serverless app. So think about e-commerce. You go to a site, you place your order, You get an email that says order confirmed. All this stuff happens behind the scenes where someone has to pick an item from inventory. They have to create shipping labels. They have to charge your credit card. All this stuff is going on, and sometimes at massive scale, right? Think about Black Friday, where you might have hundreds of thousands of these events happening in a very short period of time. So some of the requirements that we receive from these e-commerce people when it comes to serverless are, yeah, we need to be able to process at very high volumes without slowing down tremendously our latency. Much of this processing can and should be done asynchronously. It would be a massive pain if you clicked order at walmart.com and that little circle thing kept spinning all the way until somebody had put your item in a cardboard box and sent it to FedEx, right? You'd be waiting there spinning for a very long time. You really don't need very much to happen when the customer intends to place an order. Most of it can happen asynchronously. It can happen after they place the order. Go kick off a process that will go take care of it. Make sure you end up with them having the package at their doorstep. But you need at least once delivery. You cannot have a world that you get that order confirmed page and a week later the item is not on your doorstep. Okay, you need at least once delivery. It is vitally important that every single message is received to completion at least once. Ordering is also very important. This comes to us from a large set of our e-commerce customers. The difference between somebody place an order, cancel an order, I need to make sure I'm processing those in the order intended, right? I can't complete a cancel request until the order request happens. And so they need to make sure they have ordering. And another interesting behavior, and if you're familiar with streams like Kafka, sometimes they want to be able to replay or reprocess events. There might be instances where a bunch of orders come in and there was some processing error. And they're like, oh, shoot, I need to go back now. Let's do the last 3 minutes worth of transactions. I actually need to go rerun those ones. So let me push the rewind button, go back 3 minutes, and trigger all those functions again. So these are not unique requirements. This is something that I'm imagining even many of you might have run into scenarios with some similar requirements to this. So how could you perform this? And by and large, what I would recommend when you're looking at some of those requirements like that is you want to use something like Kafka. You want to use a message stream. And it doesn't have to be Kafka, but something Kafka-like. Because Kafka, this messaging pattern, does a few things that are really beneficial. For one, it creates for you ordered partitions, lots of them, as many as you might need, which means that you can guarantee ordering for a partition. So you could partition messages based on like a customer key. You can have as many of those partitions as you need, but you can guarantee that a message in a partition is processed in order. So if Jeff places an order and Jeff cancels an order, Kafka guarantees through its partitions and its partition locking that those will be received in order. Okay, so that's really nice. You also get this cool behavior in streams called checkpointing. So you can see in the slide here, I have these green arrow, this blue arrow, in this whatever color, maroony, brownie, orange, whatever arrow. This represents the checkpoint. So here I've got these consumers. You can imagine these as serverless functions. And it's saying like, hey, yeah, I see all these orders have been placed. Right now I'm on order, 4. That's the next one I need to get. Here I'm at the beginning of the partition. Here I'm in the middle. I can progress those checkpoints forward after I process the messages. Or I can send a signal back and say, you know what, I actually want to put that checkpoint back in time. I want to go reprocess all the messages in this partition. It keeps them around. Kafka doesn't purge things until you tell it to. And so I have this flexibility to have these checkpoints so that not only do I get at least once delivery, I also have control to replay and checkpoint and only progress that processing when I give that signal back. So this is pretty cool. This is why people love Kafka. This is why retailers want to use Kafka with their functions. So I have this nice messaging pattern of a message stream. It provides all those capabilities that are required from the list here. Check, 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 check. It does all those things we talked about. Now, the problem is one of the main approaches that we see in the open source world, this is a pattern I'm not a huge fan of, is that you will have a serverless provider or a serverless platform, and it's like, hey, you can build these really cool functions, but we're going to make everything speak HTTP because HTTP is super easy. Remember, that's why people start with it. And then they're like, well, I'm a retailer, so I want to use Kafka. And they're like, that's cool. You can use Kafka. And we're going to give you this Kafka to HTTP or gRPC adapter. we're going to give you this adapter that's going to pull in these Kafka messages and fan them out and shoot them out as HTTP messages to however many functions that you might have, however many container instances you might have, you name it. And so this works, and it works for certain scenarios, but it would not work for those e-commerce scenarios that I mentioned. At least it wouldn't work without heavily compromising things like throughput. Because if I have this single instance Kafka adapter that's getting thousands of messaging and just spewing them out, so it's like you take an HTTP, everybody gets an HTTP message. How do you make sure that message 2 doesn't start processing until message 1 is complete? In an HTTP world, that might mean you only send one message at a time. You wait for it to come back, and then you send the second message. But that really slows things down. In Kafka land, you're pulling in and processing these huge batches. So that becomes a little bit more challenging. How do you make sure this Kafka adapter now doesn't become the bottleneck? What if I am getting those thousands of events? How do I make sure this Kafka thing can keep spewing them out as fast as I need? And that's now scaling, and my functions are scaling, and it's a little bit there. And the other one is if I'm just writing HTTP functions in my serverless function land, if I'm a developer and now I want to say, hey, progress the checkpoint, pause the checkpoint, rewind the checkpoint, replay the checkpoint, how do I expose that now? And it gets a little bit wonky because if you see from the graph, very often the people who are managing like your Kafka broker and this adapter as part of your serverless platform, that's going to be your operators. How do your developers now access these native Kafka capabilities that are abstractions now? You've abstracted Kafka away, which is nice from one standpoint. Hey, I don't have to learn Kafka principles. I don't have to worry about Kafka things. But in the same way, it's a little bit like taking those RGB cables, plugging them into an HDMI or an HDTV. Yeah, it works, but are you really taking full advantage of all the goodness that Kafka provides? So the pattern that we use in Azure Functions that I'm a huge advocate for is enabling your serverless functions to directly communicate, at least very easily communicate with those Kafka streaming APIs. Can you remove that middle, let's convert everything to HTTP adapter, right? And now your developer, yes, they may need to learn a little bit more about Kafka. They may need to learn about these new cables and these new wires, but a whole new world is opened up to them. And now I can do this order processing at scale, guaranteed delivery at scale, replay, checkpointing, you name it, okay? This is a must-have for us. If we did not have this capability, a large set of the large Azure Functions customers that are taking those 500 billion executions could not use our service. All right, let's do another example, banking and other financial institutions. This is another big one that I've spent a lot of time on calls with in discussions with architects and developers. A few properties that they have. I'll go through this one a little bit faster. Transactions need to be handled with guaranteed delivery. If somebody says transfer $1 million, that better happen. You don't lose that message. Messages are life. That cannot just evaporate in the vapor of the internet pipes. That has to be guaranteed. But you also need these rich semantics. I get a request to process $1 million transfer. I might want to retry that message. Hey, I tried to transfer your money. I hit an issue. Someone else should give this a shot later. Okay, that's a very explicit gesture. Retry that message later. We call that abandon in a many queue semantics. You might want to fail the message. Hey, you told me to transfer $1 million. This message is just poison. It's bad. No one should waste their time on it. Go stick this in a dead letter queue. Or you might say, hey, this is all cool. Complete the message. I, as a developer, want to be able to explicitly choose at the conclusion of my function which of those three things should happen. Okay, that's important to me. Dead letter queues are really important too, because if I do end up failing $1 million transfer, I better have a place that I can go see, here's all the ones you failed. Do you want to requeue them? Do you want to inspect them? Do you need to repair them? I want that dead letter queue. I really want that dead letter queue. One slow transaction shouldn't hold up future ones. So if I have all these transactions in my queue, ideally, if one transaction takes 3 hours, the rest aren't sitting there waiting. I can continue to process the rest throughout. I think of queues often like a airport line, where you have one big line to check into an airline, but there's multiple kiosks, like multiple Delta agents, and each one could take someone. A single person might be taking 2 hours changing their ticket, but while they're taking 2 hours, the other ticket takers are calling the next person in line. And similar to the financial one, I could do a lot of this processing asynchronously. You tell me to do a transaction, I tell you I will take care of it in the next hour. The rest happens behind the scenes with all these guaranteed deliveries. So kind of I mentioned this through the pattern. Here I want to use a queue. And I kind of mentioned not only do I want a queue, I want a queue where my function, the queue consumer, can explicitly say things like complete, abandon, or dead letter. And if I say dead letter the message, I want it to go into that dead letter queue. And if I want to scale this, if I have a million of these transactions coming in, I can get multiple instances of these functions and they'll act as competing consumers. Really common pattern with queues, if you're familiar with it, where I can scale that serverless function to the moon and they just keep grabbing next in line, next in line, next in line. You're complete, you're complete, you're complete, you're dead lettered. I'm going to abandon you. Another consumer can try you later. Okay, really cool pattern, really important pattern. But, right, should I just do a queue to HTTP adapter? Should I just have something that dequeues things and shoots out a bunch of HTTP stuff? Maybe, but how are you going to solve for the rest of this? How do you now expose complete, abandon, dead letter within the developer realm? Do I now have to have some like, yeah, you're going to get an HTTP request, but if you respond with a 401, it means abandon. If you respond with a 404, it means dead letter, right? You could do it. You could define all of the things that RabbitMQ or NATS or whatever does by default, but now you're kind of just creating your own protocol on top of queues to provide these same guarantees. So again, I say, don't do that. Let them connect directly to the queue. So the big counter to this, though, is, yeah, Jeff, sure. You're saying let serverless devs talk directly to the queue, talk directly to Kafka, let them have all these guarantees, let them take advantage of all the innovation that these message brokers are creating. But doesn't that make things really complicated, right? In serverless, I want to get things done really quick. I don't want to have to go learn about complete, abandon, and dead letter. That's too much work. Now I have to learn all these new patterns. So I do think that there is a nice middle ground. And this is where I think the role of a serverless runtime comes in. This is a concept that I feel, as I get involved with the serverless community in general, is a really misunderstood concept. What is a serverless runtime? Well, for me, the definition I'm going to explain it with is the runtime or the host are those bits that run alongside the user or developer code, either within the same container or as a sidecar within the same pod. But these bits are really close. In the Azure Functions world, the runtime is the thing that actually invokes the user code. It's the bits that knows how to call the user code. It does the universal logging. It adds a bunch of value adds, but it's running right alongside the code. They run right by each other. Now in Azure Functions, we make that layer, the runtime, the thing that runs right next to your code, that's responsible for talking to the message broker. So the runtime can talk to RabbitMQ and send that queue message to the user code. They're running within the same context, so these two can talk to each other and decide what to do with that message. It's not a single kind of like HTTP adapter and then you go into HTTP land. They run right next to each other. So in general, we found a lot of benefits by moving these messaging semantics closer to the code within the same pod. I don't care if it's a sidecar or the container itself. Just stick them as close as you can as possible. Okay. So, for example, here's this in action. This is a RabbitMQ Python example. This is what it would take to just write a RabbitMQ function directly against the RabbitMQ APIs. There's a lot here because I have things like a dead letter that I'm defining. I have things like, am I completing the message? Am I closing the connection? So you can see this is a lot of code. I'm not going to lie to you, that's a lot of code. But we can simplify that. If we pair this with a serverless runtime, this is what this exact same code looks like when you use this within Azure Functions Runtime. So our runtime is doing this exact same code, but I don't want to say abstract because I said that with each. It's not abstract. It's still happening. It's the exact same contract, but we're taking care of it for you. It's a simplified SDK. The runtime here is just a really nice library that does all that code, and it makes it so you only have to write this code. All you have to write is, I want a queue message. This is the code I want to write. But I still have access to things like dead letter this thing, retry this thing, complete this thing, because the RabbitMQ connection is right there. It's right next to me. It's not in some HTTP adapter. It's right at the thing that invoked my code, okay? So this is the pattern that we use with Azure Functions. As an FYI, open source. You can write a function app like this. You can containerize it. We'll stick that functions runtime next to your code, pop it in a Docker container, and you can deploy it with Kubernetes. In fact, putting it all together, as I kind of wrap up here, you can now have something like Kafka. Kafka talks directly to that function container because our Azure Functions runtime is hanging out right there. Your user code is there. It's using those streaming APIs. It's not talking to Kafka with HTTP. Your user code is talking to Kafka through Kafka APIs. And then we use Kata as the thing that scales this so that you can scale these function consumers as you need. I love this because now all of the Kafka consuming code is the developer land. The developer is working with the functions runtime. The developer is working and testing and programming against the functions programming model. So if there's an issue with Kafka, the developer is the one who can settle it. Okay, so key takeaways here. If you want your users to leverage your platform for mission critical workloads, your platform needs to support mission critical patterns. If you don't support the patterns, you can't expect people to use your platform for these mission critical workloads. They'll only use it for workloads that your platform supports. So consider, how can you bring these capabilities to that developer domain space? How do you expose this more cleanly, more naturally to make that HDTV show HD pictures? And finally, this is our learning so far, but we're here because we want to work on this together. And so if you have questions, if you have comments, if you have counterpoints, hit me up. Tag me at Twitter, at Jeff Hollan. More than happy to chat with you. Thank you so much for your time. Hopefully this inspires you with conversation at least, or some key takeaways. So thanks all so much and enjoy the rest of your conference.